multiplying polynomials with the box method. We've got 3x times parentheses 2x squared y plus 7. So what we want to do is we want to make a rectangle, a big rectangle. The area of this outer rectangle is going to be the whole product here. And we're going to split it up into actually two smaller rectangles like this because we have two pieces in the parentheses. We need two parts for these two pieces. And then we label the sides. So we've got our 3x here. So 3x is our length. And then we've got 2x squared y. So let's make the width of the first small rectangle 2x squared y. And then we got plus 7 here. So let's make the width of the last rectangle 7. And then we just multiply. So we take, using the area formula for rectangles, area equals length times width. So the area of this box is 3x times 2x squared y. And when we multiply coefficients. 2 times 3 times x squared. We combine the x terms and then the y terms. So 2 times 3 is 6. X times x squared. There's 1, 2, 3 x's, so x cubed, and then a y. So the area of this box is 6x cubed y. And then we do the same thing for the second box. We got 3x times 7. So this is 3 times 7 times x. If we rearrange the terms using the commutative property of multiplication, 3 times 7 is 21. And then we've got our x. So the area of the box is, and this is going to be our final answer, it's going to be 6x cubed y plus 21x, because that's the sum of the areas of the small rectangles that combine to give us the big rectangle. All right, so let's do that one more time, and let's actually use an example where we have 3 pieces inside the parentheses, 3 terms in the parentheses. So we're going to need 3 small rectangles. So our big rectangle here, and then we split it up into 1, 2, 3 rectangles. All right, so let's label our lengths and widths again. So we got 4x squared this time, and we're gonna have 2x cubed, 3x, or negative 3x I should say, and up plus 5. So let's make 4x squared the length, 4x squared. 2x cubed is the width of the first rectangle. The next rectangle, we're going to make negative 3x. We're going to keep track of that negative sign because that belongs to the 3x. And that's important information. And then the last one, we're going to make it a positive 5 as the width. 2x cubed minus 3x plus 5. The total width here is what we have in the parentheses. And we multiply it out again, 4x squared times 2x cubed. We end up with 2 times 4 times x squared times x cubed. So that's 2 times 4 is 8. X squared times x cubed. We add the exponents because the bases of x are the same. 2 plus 3 is 5. 1, 2, 3, 4, 5 x's. Same thing for the middle middle rectangle. We got 4x squared times negative 3x. So this is 4 times negative 3 times x squared times x. So negative 12x to the 3rd power. And in the last box, we got 4x squared times 5. So that's 5 times 4 times x squared. So 20x squared. And we put it all together. We've got these 3 areas combined, give us the area of the outer rectangle. So this is going to be a x to the 5th minus 12x to the 3rd plus 20x to the 2nd. And so before we wrap up, we could have done this without boxes using the distributive property directly. The way that would have worked is we take the number out front and we just multiply it by each number inside, each term inside the parentheses, and you get the same result. And this box diagram is just a visual representation of this process.